It's a very good afternoon. Welcome. Today I'm going to go through the preparatory examination 2025 Geography Paper 1, Section B. I'm going to cover only Section B. I'm going to cover Section B, which is Mapwork. So, like I always emphasize, guys, whenever you are going to answer the question for your Section B, the first thing that you have to do is you have to go through the background information. Let's go through it. Geography skills and techniques, background information of Malelane. Let's go through the information. Okay. Malelane is a gateway to Kruger National Park, Mozambique, and Eswatini, formerly Swaziland. This charming farming town, so already this farming town is a gateway. I think these are some of the words that you should take note of. In this charming farming town in Mpumalanga is situated on the N4 highway, about halfway between capital city of Mpumalanga. So already I know that, okay, this farming that is taking place in that town is a farm town. Secondly, I know now that it is in Mpumalanga province. Before I even go to check the question, okay? Nelspruit and the capital city of Mozambique, Maputo. Okay. Malelane sits on an intersection of 3 roads that lead to many of the Southern Africa's favorite tourist destinations. Driving into Malelane from Nelspruit, you can see the hill crop directly ahead with the Mozambican border post nestled at its base. Turn left and promise of a few glorious days of the Kruger National Park reckons you. Turn right and lush tropical landscape of Eswatini lies on the horizon. Okay, so what do we have here? Background information. The area is Malelane. You can see here, these are the coordinates and some of the information that is there. So I always emphasize, guys, that whenever you are doing Mapwork, especially Section B, go through the background information. This is what I've read. Let's go to the question and see what they're going to ask. Okay. So the first thing is, refer to the topographical map and the orthophoto map. This is the map of Malelane. This is the topographical map. You can see it's in color. This is your orthophoto map. How do you recognize the two? The first thing is the scale of a topographical map is 1:50,000. That is the scale. Number 2, the second thing about the topographical map is your contour interval, which is 20 meters. Okay. About your orthophoto, the scale is 1:10,000. Then you can see also at the bottom, the contour interval is 5 meters. So the other also thing that differentiates the two, this one is in color. Topographical map is in color, whereas your orthophoto is in black and white. Remember, this is a photograph, this is an image. Okay, this is a photograph, this is in what? An image. Okay, let's go through the question so that I don't waste your time. In which province is Malelane located? So if you can check here, guys, where am I going to get the answer? You can see here the charming farming town in Mpumalanga. So that is the correct answer there. It's located in MP, that is your Mpumalanga, which is C. The grid reference of the number located east of Malelane map. So when you are doing this now, this is how we do it. Map referencing, this is how we do it. I'm going to do it like this, okay? So let's break down the numbers that we have here. So your 25 degrees here is your latitude. Your 31 is your longitude. Remember, we have got 25, 31 BC. So I'm going to break it down. So your 25 here is your latitude. Ne? Then your 31 is your longitude. So when they are doing maps in South Africa, what do? They divide the whole grid into 4. That is your A, B, C, and D. So the B that you have here is the bigger block. This one is a what? It's a bigger block. Bigger block. So it means now 25 is your latitude, like I've already said. This is your latitude. And your 30 is your longitude. Let me break it like that. Is your longitude. So B is the bigger block, which means the bigger block, which is this one. This is the bigger block B. That is the bigger block B. So they don't leave it like this. They further divide each bigger block into 4 again. Then means we are going to further divide each block into 4 again, which means in A we have got A, B, C, and D. In B we have got A, B, C, and D. In C we have got A, B, C, and D. In D we have got A, B, C, and D. So the question now is saying the grid reference number located east of the Malelane map 2531 BC. So 25 is your latitude, 31 is your longitude, B is the bigger block, which means we are in this bigger block. Then C is the smaller block. Smaller block, which means we are in this bigger block B. Then where is our C? Our C is here. This is where our C. So this is the area that we are talking about when we only talk in relation to 2531 BC. 25 latitude, 31 is the longitude, B is the bigger block, C is the smaller block. So the question is saying the grid reference number located to the east of Malelane map. All right, what is on the east of 2531 BC? You can see is this one, is D. So which means your answer there, the latitude is still the same, the longitude is still the same, the bigger block is still the same. What has changed is only the smaller block, which is on the east of the smaller block C. So our answer there will be 2531 BD. Let me redo it again, okay? So what we have here, you have to know 25 is your latitude, 31 is your longitude. Your B is the bigger block. That's why we said A, B, C, D. We had 4 blocks before we subdivided them. So this is the bigger block B. In this bigger block, there's a small block C, which is this one. So that is your 2531 BC. So what is to the east now? Remember, east is always on your right. What is to the right of C is D. So your answer will be 2131 BD. That will be your answer. That will be your answer, which means your answer there is what? Is A. Let's move on to the next one. Refer to the orthophoto map. Please make sure whenever you're doing Mapwork, you have to use the correct map at all the times. Refer to the orthophoto map. This is the orthophoto map that we are supposed to use. To refer to the orthophoto map, which means this is your what? Your map. This is the map that you're supposed to use, because the question is saying refer to the orthophoto map. So what is the question? What is the difference in height between contour line at 7? Contour line at 7, of course, contour line at 7 you can see is there, okay, and the spot height 8 on orthophoto map. Okay, so let's try to check now. You can see your 7 here. It's on 300. Your 7, that's what the way the arrow, this arrow is pointing at, is on 300. Okay, which means your 7 is on 300 what? Meters. Let's go to the spot height at 8. Spot height at 8. Spot height at 8. You can see here what do we have? That is 382. You can check nicely. 382. 382. So at 8 we have got what? 382 meters. 382 meters. So these are the two height markings that we have. So what did the question say now? What is the difference in height between spot height, contour line 7 and spot height 8? So this is the contour line 7. You can see here there is okay, you can see here 300, you can see 300 here, 295. Remember there's a contour interval of 5. Then from there it goes to what? 300. So that is your 7 where this arrow is pointing at. If you come to your 8, you can see the way we have got our 8. I want to bring it closer. Can you check what we have? Can you check? We have got 382. Okay, that's what we have there. So we have got the highest height is what? 382, which means there, what we are going to do now is we are going to say now 382 meters minus 300 meters. What do we get? 382 minus 300. What do we get here? We get 82 meters. We get 82 meters. That's what we get. Which means the answer for this one is what? 382 minus 300 meters. And you get what? 82 meters. Okay. 382. Okay, I'm supposed to write meters here. 382 minus 300. Then you get your what? 82 meters. Okay, what is the next thing? Use the answer in question 3.1.3 to calculate the gradient from the contour line at 7 to the spot height 8. Use the map distance. So what is happening here? We already have our VI. Our VI, which is 82 meters. We also have been given the map distance for our HE. We have been given the map distance is what? 4.5. 4.5 centimeters. Okay. So the next thing is for what you have to know is how do we calculate our gradient? I'll just say gradient. Okay, let me just write it in full. Is equal to our vertical interval over the horizontal equivalent or the horizontal distance. That's how we calculate gradient. So what is our VI? We have actually got our VI by subtracting 382 minus 300. So our VI then is what? 82. Please don't forget to write the unit of measurement. Then our HE now, we have been given the map distance. So which means we are going to multiply the map distance multiplied by the scale of the map that we are using. Remember, it's saying refer to the orthophoto map. So our scale is supposed to be in meters. All right. So what do we have? This is our orthophoto. The scale of our orthophoto is 1:10,000. Remember, this is in centimeters. Sorry. This is in centimeters. 1:10,000 centimeters. So we want to convert it in meters so that we can multiply our 4.5 times the area, the scale of our orthophoto in meters. So if you want to convert it in meters, it means how many centimeters are in a meter is 100, which means we are going to divide these 10,000 centimeters by 100. What are we going to get? We get 100 meters. So it means here for our 4.5 centimeter, we are going to multiply it by 100 meters. Why are we doing that? Because our orthophoto now, we have converted, we have changed our scale of 1:10,000. We have changed into meters, which means we simply divide by 100. 100. Okay, that makes it 1:100 meters, which means 1 centimeter on the map represents 100 meters on the actual ground. That's what we have done. That's why we are multiplying here 4.5 centimeters, centimeters multiplied by 100 meters. That's why we're doing that, because already we are given the map distance. So what do we get now if we multiply? So we have got our 82 meters. Let's see now. 4.5 multiplied by 100. Okay, what do we get? We get 450, which is 450 what? Meters. Okay, so what are we going to do now? Remember, this is still a fraction. We want to simplify it. We are going to divide by the VI, both by the VI, which means our VI divided by VI, our horizontal equivalent divided by VI. What are we doing here? We are dividing 82 meters divided by 82 meters over here, 450 meters divided as well by 82. That's what we are doing. So 82 divided by 82, what do we get? We get 1. Then 450 divided by 82, what do we get? We get 5 point. I'm going to round off to the next two decimal places, which means it will become 5.49. 5.49. That's what I get. So I'm not going to leave it like that, because you cannot leave it as a fraction. You're supposed to write it as a ratio, which is 1:5.49. So this will be our answer. This will be our gradient. 1:5.49. 1:5.49. What did we do? the first thing is we calculated our VI, which is our vertical interval. That was 382 minus 300. That's how we got the 82 meters, okay? Then we were given this map distance of 4.5 centimeters. So we multiplied this 4.5 centimeters multiplied by 100 meters. Why? Because we have converted our orthophoto scale from 10,000 and we divided it by 100 so that we change it or we convert it to meters, and it gives us what? 100 meters. So what it simply means is, now when we change our orthophoto scale from centimeters to meters, it becomes 1 centimeter on the map represents 100 meters on the actual ground. Okay, so we simply divide it by 100. So after that, 82 over 450 meters, we divide both by the vertical interval, which is 82. So it's 82 meters divided by 82 meters, 450 meters divided by 82 meters as well. What do we get? We get 1 over 5.49. Okay, then we don't leave it like this. This is wrong. We have to write it as a ratio. 1 is to 5.49. That will be our gradient. That will be our gradient. Okay, let's move on. Then refer to the answer in question 3.1.4. As at this gradient, there will be more, will there be more infiltration or runoff? Okay, let's interpret our gradient. If gradient is less than 10, it means it's steep. Okay, so we are looking at what we got here is 5.49. It's 5.49, which is less than 10, which means it's steep. Okay, if it's between 10 to 15, it means it's moderate. If it's more than 15, it means it's what? It's gentle. That's how you analyze your gentle. That's how you come to the conclusion whether it's steep or it's gentle. So if it's less than 10, it's steep. 10 to 15 is moderate. More than 15 is what? It's gentle. That's your interpretation of gradient. So from what we have now, at this gradient, there will be more infiltration runoff, which means it's steep because it's 1 is to 5.49. It means what? It's steep. And where the slope is steep, it means that we have got more surface runoff as compared to infiltration. Why? Because water is not allowed to settle on a steep slope. As soon as it rains, it starts flowing down. So it means we'll have more of runoff than infiltration, because it's only on gentle slope that water is allowed to settle. As it settles, it starts to infiltrate. So in this instance, since our gradient is 1 is to 5.49, which is less than 10 according to the interpretation of gradient, it means that it's steep and then it favors more surface runoff. Okay, that's what it means. It means it favors more surface runoff. Okay, so that's 3.1.5. okay, so steep gradient results in more runoff and gentle gradient results in more infiltration. Let's move on to 3.2. 3.2, what we have on 3.2? 3.2, it reads, that's map interpretation. A lot of learners struggle with map interpretation. A lot of learners struggle with map interpretation. I want you to pay attention now. Okay, this is linked to the content that you have covered. Especially this is paper 1, which means part of your geomorphology, part of your climate and weather. Let's see what we have. A wind that blows at night from spot height 405. Okay, let's start here first. Refer to the topographical map. Refer to the topographical map, which means we are using this map now. We are using this map. So a wind that blows at night from spot height 405 in block B3. Block B3, okay. Block B3 from here, okay, which means this is more like a valley. In a westerly direction to Umgwenya River is known as the, remember, this is in a valley. During the night, what comes to your mind? Of course, what comes to your mind? Katabatic, anabatic, no, this is wrong. Katabatic, obviously, this is during the night, which means there is cold and denser air that is sinking. You understand? So your answer there will be katabatic. Anabatic is during the day and is associated with warm air that rises. Okay. When you talk about berg winds, of course, we usually have this in winter, where we have got wind that blows from the interior, that from the Kalahari to the coastal low. So your answer there is katabatic, is within the valley. It's katabatic. Okay. Then what we have, identify the negative environmental, that is B now. Identify the negative negative environmental impact that the wind identified the 3.1 can have on the Leopard River Creek block is staged in block B2. In block B2, what will it have? This is a valley. This is during the night, which means we are likely to end up having what we call the frost pockets. So the frost can kill plants or vegetation. That's what will happen. The frost will kill plants or vegetation. Our frost pockets, obviously, when the temperature is below 0 degrees at the bottom of the valley, that's when we have got the frost pockets. So obviously, the frost will kill plants and vegetation. That's what will happen then. Then refer to line F to G in block B1 and B2 on the topographical map. Okay? Block what? F to G. Where is our F to G? All right. F to G, you can see there's our F, there's our G. That's what we are referring to. Okay. B1 and B2. This is B1 and B2. Okay. Obviously, you can see that we have a meander here. This is a meander from there. So here, what they are indirectly asking you is the cross-section of a meander. Okay. So what we have? Draw a cross-section along the FG across the Ungwenya River. Provide the following labels on your cross-section. We have got the undercut slope, we have got the slip of slope. Okay, so we want to find out now, where is erosion dominant? Is dominant on F because it's the outer bank. Deposition is dominant on the side where we have got G because there's more, because the velocity of the water is lower as compared to F. Here undercut there is more erosion because there's high velocity, it's more erosive as well. So we're going to end up having something like this. Okay, there is your F, there is your G. Okay, what do we have? Of course, it's gonna be, then here it's more like this, which means this one now becomes your undercut slope where erosion is taking place, and this one becomes your slip of slope, becomes your slip, oh my spelling, of slope. Here deposition is taking place, that's why it's shallow. Here it's deeper because it has been deepened by erosion that is taking place on the outer bank. This is the inner bank. So you can see here is the slip of slope where we have got G. There is the undercut slope. So the question is asking you to show the undercut slope and the slip of slope, which means this is your undercut slope and this is your slip of slope. Where erosion is taking place, the river is more erosive on the outbank and is depositing. There's more deposition on the inner bank. That's why you see it's shallow. Here it's more deeper. So this will be more like your cross section from your F to your G, which means here is been deepened due to erosion because the river is more erosive on the outer bank. The water is traveling at a very faster speed, or what we call a high velocity. So that's what makes it more erosive on the outer bank. On the inner bank, there's more deposition that is taking place. So you have your undercut slope, then you have got your slip of slope there. Give one physical reason why the Leopard Creek Golf Course is located at point G rather than at point F. So your point B now, what is happening? Of course, you can see what we are saying now, Leopard Creek Golf, okay? Where is it located? Why? Because there's more erosion at F. Here, there's more erosion at F because here there's more erosion. That's where you've got your undercut slope. That's where you've got your slip of slope. There's less erosion at G because there's more deposition taking place. More deposition at G, there's also less risk of flood at G. That's what this is all about, okay? Let's move on to the next one. Identify the fluvial feature H on C2 on the topographical map. The fluvial feature F, the fluvial feature H on C2 on the topographical map. 3.2.3 is H. Let's find out where we have got our H. So you can see that it's along the channel. This deposition that has taken place which resulted in this sand island. Okay, this is how the braided stream is formed. So it's a braided stream. You can see deposition that has taken place along the channel. Okay, so which results in sand islands. This is what caused this braided stream. So you've got the sand islands here. So the answer there is a braided stream. It's a braided stream. It is formed due to deposition of sediments on the stream, which result in these sand islands, as you can see, this and this. So it's a braided stream. So there we have got what? A braided stream. That's a braided stream. The feature identified in 3.2.3 is commonly found in the, of course, 3.2.4. 3.2.4. Where is it commonly found? So where is it commonly found? Where is it commonly found? So you can see meanders, we find them in the middle course of the river. I know at some point we find them also at the lower course. So the correct answer there now is what? We have got the middle course where there is more of lateral erosion. There is also deposition that is taking place. So it's middle course. Where else as well? And also middle course and U-shape, because in the upper course there is more vertical erosion that is taking place. As a result, we have got a V-shape. So our answer here will be C. We find it in the middle course and the V-shape. Okay, V-shape valley. Okay, let's move on to the next one. 3.2.5. It reads, what is the general direction of the flow of Umgwenya River on the topographical map? So 3.2.5, if you look at this river, in which direction is it flowing? The first thing that we do, let's look at the angle at which the tributaries are joining the main river. You can see here at acute angle, you can see there at acute angle, which suggests that it's northeast. Can you see? Check here at acute angle here, at acute angle here, at acute angle, the tributaries you can see here as well at acute angles. That's how they're joining the main river, which suggests that it's flowing in a northeasterly direction. It's flowing in a northeasterly direction. We are looking at the angle at which these tributaries are joining the main stream. Can you see here? Okay, which means it's flowing towards this direction because it's joining at acute angle. You can also check here how it's joining the main river. You can also see how it's also joining the main river here. So it's in a northeasterly direction. Okay, northeasterly direction. Let's move on to GIS now. 3.3, it reads, river at the dam in block A5 on the topographical map. Okay, A5. Okay, A5 on the topographical map here. That is A5, the river on the topographical map. Okay. Is the dam an example of vector raster data? The moment we talk about topographical map, obviously you know that is vector data, which means the features that are on a topographical map, they are shown as lines, points, and symbols, or line, points, and polygons. So whenever we talk about the topographical map, that's vector data. Topographical map, that's what? Vector data. We are saying topographical map, that's what? Vector data. Topographical map. When you talk about orthophoto, then we talk about what? Raster data. We talk about raster data. Okay, so the question is saying, refer to the dam in A5 on the topographical map. Whenever we mention topographical map, that is vector data. Okay, so our answer there is what? Is vector data. Okay, give a reason for your answer in question 3.3.1. Obviously, vector data is given in lines, points, and symbols. Like I was saying, lines, points, and symbols. What we are simply saying is, you can see here, what do we have here? Cultivated land. That's a polygon or area symbol. I'm just giving you an example. We have got a river. That's a line symbol. We have got the tributaries. We have got the trekking line. That's a line symbol as well. Then we have got the spot height here. That's a point symbol. Okay, just to give you, we've got buildings as well. That's a point symbol. So the vector data on a topographical map, they are given as line, points, and symbols. Okay. Then what else? Define the term buffering. Define the term buffering. Is the process of demarcating an area around a spatial feature. You are demarcating an area around a spatial feature. That's what buffering is. The process of demarcating an area around a spatial feature. That's what buffering is, of course. That's what buffering is. Then identify the land use feature J on the in block A4. A4 J, what is it? Okay, we can just come here and see. This is the protected area. Can you see? It's protected area. that is your J. This is what we are referring to, is the protected area. We are referring you can just go to your reference, protected area. That is your protected area. Explain how the land use feature identified in question 3.3.2 is an example of buffering. Demarcation of an area around a river is demarcation of an area around a river where there's risk of flooding. Demarcation of an area around the river where there's risk of flooding. That's how buffering is done there. No developments allowed in the protected area because it's protecting this one, okay, the river. That's basically what we are talking about. So I'm saying the demarcation of an area around the river where there is a risk of flooding. That's what this is all about. Thank you so much.